Hello. Hello, good morning, everyone. Am I audible to everyone?
Yes, sir.
Yes.
Good morning, sir.
Yes, sir.
Good morning.
Good morning.
So, very good morning, everyone. Today, in today's session, we will start with the next chapter of detailing. So, in the previous sessions, we have completed the foundation details, right? We have completed the foundation details, and we have also seen the various different types of footings. So from today, we will start from the next vertical member in the building, that is the column. Once we will do the columns, we will also understand how the vertical members, that is shear wall detailing. So basically, we have to complete basically we have started from the footing, which is the initial member of the building, and then we are going through the vertical member. Once we will complete the vertical member, we will go to the horizontal member, that is beam, and then after the beam we will reach to the slab, and after all these things we will have to see at last the stairs, the most important part. Okay, so one by one we will go through all. I'll share my screen so that let me know if you can see my screen. uh, is my screen is visible to everyone?
Yes, sir.
Yes,
Yes, sir.
sir.
Well,
Okay, so again I have opened this SP34, which I have already shared to everyone. Hope you have also seen the SP34 now. Okay, so in the SP34 seventh number section we have columns, right? So before we are starting the columns, we have already worked with the foundation, right? Have you done the practice of footings and foundation? Yes, everyone. Have you all
Yes, sir.
done the practice?
Yes, sir. Little bit.
yes, sir.
Okay. Some of you have already asked me in questions in the dishes. So, uh, like Kazi and Badru, not Badru has come to ask me the session in the DCS. Also, Anuj questioned me, but anyway, you guys make sure to practice the things which I have discussed in the session so that you will well aware with the things, because see, in the structure it will be connected. Once you will learn the footing, you have to learn the column, and then you have to learn the shear wall. So it is like connected with one another. So it's better to practice just after the session so that you will be having confidence to work with all the different members in the structure. Okay, so make sure you guys will practice very much well for all the different things which we have discussed in the session. Okay, make sure to ask all the questions which is required generally when you are doing the practice. Okay, so let's start with the new project again. So I have taken the structural template. Okay, so in the structural template you have all the levels plan. Okay, so level 1, let's start with the level 1. Just I will provide one basic element. First I will provide one grids, vertical grids. Okay, and then horizontal grid. Okay, same way I will provide the footings. Okay, so I have provided the isolated footing for now, and now I will start providing the columns. So when you will place the structural column, right now you can see there is these different types of columns are available. I want to provide the structural concrete column because in the concrete column only you will have to provide the reinforcement detail. Okay, so make
Yes,
sure
sir.
to provide the structural concrete column. Okay, so while placing the structural concrete column, you will still have the same option. There's two options. One is add grids, means you have to select all the grids and automatically the columns will be placed on the grids. And the second option is add add columns also available. Means suppose you are working on floor to floor, like ground floor, you have provided all the columns. Now on the first floor you want to provide the columns, so you have to select the columns. Automatically it will trace all the columns from the ground floor and it will place on the first floor. So like that, this columns will also work. So this add columns also work when you have suppose sometimes the architectural team, they have completed the building. Okay, they have completed the building, and in the building, suppose they have provided the columns with the architectural column. Okay, now it's your responsibility to convert that architectural column to structural column with a particular size and whatever the dimension based on your structural analysis design. So what you can do, you can select all the columns for the from the architectural model and you can place directly with the help of structural column. Okay, so that will help with that you can do with the this option, add columns option also. Okay, but now we have grids, we can directly place with the help of grids. Okay,
And let us just to the from this image.
sorry, someone is having some question.
No, sir.
Okay. So see, I have placed the columns and it's placed well above the footings and it is connected. If you will go to the section elevation, it is connected well and it is up to the level 1. Why it's come up to the level 1? When you have placed the column, you can notice you can notice the columns are placed on the depth, not on the height.
Yes,
So
sir.
basically, we are working on level 1, and when we have placed the column, it is basically went down,
Okay.
and up to what depth it will went down, it will went down till 2500 mm depth. Now again, if you want to place the column and you want it to place above the level 1, just like we have placed to the walls and all, so what you have to do, you have to change this to height. Okay, and up to which level you have to connect the column, you have to select the second level. Okay, so that now when you will place the column will place on the height. Let's see what will happen. Again, I will select the add grid option and I will do drag all the grids and finish it. Now you have to check in 3D or in the elevation. You can see we have the columns in the height also. Okay, so same way you have to do, but make sure in general what is the best practice to provide the columns on the height. Means in the elevation, make sure to provide another level which you call as footing level. Okay, suppose footing top. Okay, Suppose footing top level you have provided. Okay, so it's better always to provide the columns or anything in that particular level. Okay, so you have to go to that view. So right now we have created the level which is not available in this structural plan. What you have to do, you have to go to the view tab. So in the view tab, what you have, all the options, you have to create plan views for the structural plan. Okay, so select the plan. Since floor top level is not available in this view, so you have to create this view. Yes, make sure do duplicate the existing view, because if you uncheck this, all the other options will also be available, like level 1 and level 2. I don't want this right now, only I want this, the footing top level. So press OK. So you have now footing top level available. So whenever you will place anything, make sure to place the in that particular level. Okay. Now one more thing. When we have created the grids, we have created in level 1. Sometime in the another footing level or some levels, you will not see the grids. Why so? Because in the east elevation or in the elevation, you have to make sure the grids will make like comes all along the level. Okay, this already we have discussed in the architectural session. Like grids should be comes throughout the all the levels so that it is visible in different levels. So when we will drag the grids in the bottom, automatically you will see it in the footing top level. Since we have only dragged the one side grid which is visible in this east elevation, now when you will move to the north elevation, you have the different side grids that you also need to drag, so that both side grid will be visible in the footing level plan. Okay, so make sure to drag the grids throughout the levels. Okay, understood everyone? Or for better practice, what generally we are doing, we'll first create all the different levels inside our project, and then you will create a grid. Automatically it will trace all the levels. Okay, so that is the better practice. I will show you it. Suppose you want to create another grid, that is F. So automatically F will be traced throughout the level. Okay, it will be well traced throughout the all the levels inside your project. So that is generally best practice. Make sure you will do also the same. Understood everyone?
Yes, sir.
Okay. Now what we have to do the details inside the structural column. So let's start. So create one section just in the center of the column. We have the structural column. Now first place the column vertical bars from the top view. So let's start from the plan. So what we are going to do, first we have to provide the cover. Okay, so provide the cover for this structural column. Select the column, provide the column cover. So in general we will provide the column cover is 40 mm. Okay, minimum we have to provide 40 mm. So let's
40 or
give
50,
any
sir?
40. Sorry,
Sir, 40 or 50?
40 minimum we have to provide.
Okay, sir. Clear cover.
40 minimum we have to provide. Okay.
Yes, sir.
Generally 40 only we can take. Okay. So once you will provide 40 mm, I have taken any one of this. If you want to provide with your standard name, you can also provide. But that is fine. Whatever it's given, it's fine only over here also. So 40 cover. After that, you have to provide the rebar. So first is the vertical rebar I want to place. Now how the column uh, rebars we have to place. You can see it over here in SP34. So in general, so this is for the single
Yes, sir.
tie. What is tie means? Tie means how we are going to connect all the vertical members of the bar. So basically the small size column, we have to provide four corner vertical member and one single tie which will hold all the bar together. Again in six vertical member, one single tie is fine. Okay. Sometimes we have to provide two tie. So how the two tie will work? Basically, you can see there is a knot in this corner and another bandage over in this corner. So basically, there is two. One is connected for this two vertical member, this four vertical member, and another tie is for this two, this four vertical member. Okay, in this way, these six uh, vertical members are connected. Okay, best practice is for the six member is to provide one single tie which you can see in this direction in the center and overall one big tie that we can provide. I will show you one by one so that you will be also aware of this. In general, I will uh, let you understand with this one single and another one this one. Okay, and maybe one or two from this. This is for the shear wall like column. Then we have to provide something like this. Okay. So in general, all the different styles already provided in SP34. Understood? So let's start one by one. First, vertical member. So right now you can see when I'm trying to place the vertical member, it's placing parallel to the column, which I don't want. I want to place vertical. So placement play perpendicular to the cover. Okay, parallel to the cover. So what you can see now, we have the vertical member placed well inside the cover. And now what you want to select for your dia you want to select. So basically 12 or 16 based on the requirement you have to provide. Okay, so I will place one. Suppose I will place all the four. And if suppose you want to place some more, you have to decide which is the longest length in this concrete column, and then you have to provide in between that. Okay. Now this is not done right now. It's just we have placed one. But what we have to do, I will show you what we have to achieve actually. So if you can see the image, the vertical member is going throughout the column and stay on the footing bottom reinforcement. Okay. So basically we have to bend the vertical member at the very end, and we have to bend around 300 mm. Okay. Yes, this is a good prime example. So basically all the vertical members is well inside the concrete column footing, and then you have to bend. One thing you can notice, like all the concrete column is bent in such a way that it will stay in circular uh, direction, like in the radial direction, you can say. Okay, so suppose the corner bent in the 45 degree, the middle one bent in the straight horizontal degree, and the this side middle one will be bent in the vertical 40 like 0 degree. Okay, so like that you have to bend your vertical member of concrete column. So this is very good example. Like this we have to do. So let's start. So when you will go to the 3D, so we have provided the rebar over this corner. So we have to bend in the particular direction. So let's select one of the rebar, edit a sketch. Now, what is happening right now? If I'm trying to edit a sketch of this particular rebar, it's not letting me edit in this particular elevation, which is section 1. It is suggesting me to go to the east elevation. Okay, and then you can edit a sketch. Why so? Because the plane of this rebar is not in this particular direction. Okay, suppose I will go to the one of the elevation, or instead of going to elevation, I will create another section center from this, so that the rebars will be well visible. Now, when you will edit a sketch in this direction, it will allow. Why? Because the particular plane of the rebar is also it depends how you are providing the rebar. Basically, when you will provide the rebar, it is having certain plane. Okay, so it will allow in particular direction only to edit. So now we have to do 300 mm extra so that it will stay on the concrete foundation. Okay, now no need to provide a sketch for all the corners. What I will do, since I have provided on this corner, also I will make sure that I will rotate it 45 degree. Okay, so go to the top footing level again. You can see we have provided 300 mm in this direction. What I will do, I will rotate this, and while rotating, place the center on the bar vertical portion, click on the other edge and rotate it for 45-degree angle. I'll rotate it again. 45. Okay. Delete the, I don't want the copy element. Or while rotating, turn off the copy option. Okay. So like this, we have to provide the bar. Now, what you can do, delete the other side. No need to provide a sketch for the other side. Just delete that one and mirror. While mirroring, make sure the copy option is available and mirror from the center so that you will get the other side sketch. In same way, other side two bar you can also delete, and just we can mirror it from the center. Okay. Now for these two rebar, we want to provide one 300 bar, right? So suppose if I will delete this one and I will copy this one. But after copying, we have to rotate this in this direction. Okay. So I will rotate again, place the center. Either you can place it from this option or press space bar. So the placing center option will available in the rotate, rotation knob. Okay. Place on the center, click on the other side of the rebar and place it in this direction. Okay. So that you will rotate this rebar. Now once the rotation is done, this rebar is also placed well. Delete the other side and select this rebar and mirror it from the center. So like this, you can have all the rebars placed. Okay. Now if you want, sometimes there will be rebars in this position as well over here. So again, you can copy it from this and again rotate it in this direction. So similarly, you can provide all rebars. Now, someone will make ask question. No one has asked because you are not knowing these things, but I will tell you from my side, because when you will do practice, you will have question arises from your side as well. Okay, so that is very genuine. So provide the column. When we are providing the vertical member, see, once you will sketch the rebar, it will show you the options like would you like to provide this type of rebar. So automatically once you will draw the sketch, it will show you the option what you want right now. Okay, so don't get confused, it is just showing because we have just now sketched the rebar over here. So because of that it will takes one like drawing of the rebar and it is showing you right now here. Okay, but again we can select the straight one. So while placing the straight one, we have option to provide multiple rebar. That is, right now we are placing the single rebar, right? While placing it is selecting the single. We also can provide the with spacing or with fixed number. Okay. So suppose you want to select three number in this direction and three number in that direction. That also we can provide. But what will happen? See, you can provide over here three numbers. So three numbers automatically it will trace till the concrete cover automatically. If you want to provide phone number also, it will automatically trace in between this two cover. And okay. So what will happen if you want to edit the sketch of this particular section? Edit a sketch. So if you will edit a sketch, suppose 300 mm. So it will rotate all the rebar in one particular direction. And now we don't have option to rotate. If you will rotate, automatically all the rebar will going to rotate because these are in group. Okay. We don't have option to separate it from the one another. If you rotate any one, automatically all will rotate. So my suggestion is always not to provide any group rebar or spacing rebar inside the concrete column. Place it single and make a sketch, and then you can mirror it everywhere. Understood? Understood, everyone?
Yes, sir.
Any question? Okay, so don't provide like this.
Yes, sir.
Now spacing we can provide in the tie. When we provide the tie, there the spacing is must. So let's start providing one spacing. Go to the top rebar again. Okay. Select the rebar. Now select the this tie 52 number. Okay. If you it is not available in yours, make sure to load the shape from the family structural structural rebar shape. Okay. So in this you can load all at once. Okay, load all. Also make sure to load even this folders, all the different rebar shape. So once you will load, you have all the shape available inside your project. Okay. Okay. So right now we have all the shape. So that's I will load. So once you will load, now we have to do place in such a manner that it will place in this horizontal direction. Okay, in horizontal plane. Make sure the tie will be of 8 mm thickness. Okay, not less than that or not more than that. Generally tie will be of 8 mm only. Okay, so once you will place, make sure the tie corner will be placed in one corner position. Okay, so once you will place, click. Now we have to do one more thing. So because the tie is already placed well inside the cover, but you can see the vertical members are not placed in the center of the tie, which is not good. It is provided well inside the cover, but we have not provided it well inside the tie. We have to provide it. Okay, so place it manually in the center like this. Same way for all. Okay. or initially only you can provide the tie and then you can provide the vertical member. That is also fine. Now this is the single tie I have provided right now. Okay. Now I want to provide one more tie. Basically, I will provide one single tie in this direction to, to connect this to vertical member. So let's see. Just a second, I will come back. Okay, so we have to place another stirrups. Yes, so M01 I want to load. So you can see. Now, when I'm trying to place it in this area, it is going somewhere outside, but one side it is fine placed well inside the vertical member. What I will do, I will drag it from the other side. So basically it's went it till this end. I will drag it right over here. Okay. Now in the section, what you have to do, you have to check where exactly we have placed this. So this is our vertical tie, just place below it. So we have to do for this tie first, the main tie, we have to make sure to provide the maximum spacing. And maximum spacing in general, we can provide 150 mm to 200 mm or 300 mm, whatever it's mentioned in the drawing. Suppose 150 mm it is provided. So like this, we have to provide. Now you can notice like the columns stirrups is provided till here, but certain stirrups will be provided inside the footing as well. You can see over here as well. Certain stirrups is going inside the foundation area. Okay. And we have looked the isolated footing option as well. There the stirrups, you can see it is up to the foundation. Okay. It's not up to the foundation. Basically, 150 mm spacing started from the bottom. Okay. So from this area, you have to start 150 mm and then you can start placing. Okay. Now the another single tie which is just connecting the vertical to that will also you have to provide maximum spacing of 150 mm. So right now it is placing inside the foundation. Make sure to provide it in column and at the end of the column also till the end of the column. Now one thing you all notice, our rebar is connected, not connected till the end of the foundation, like columns to column. You have seen in general practice in the real project, you have noticed the rebars of columns are provided above the floor. Okay, like it is extended well above the floor, so that the next floor when we will start, we can bend the first floor column and basically we have a lap length, overlap length. Okay. So like this, we have to give the overlap length. So how we have to do that, I will show you. Basically, you have seen this type of bend when we are going from floor to floor. Okay, like this. But this is not a good practice. Right now, it's provided at very one area, all the bends. But a standard way of practicing is we have to provide alternate position. Maybe suppose there is 6 bar. So one bar bent is over here, another bar bent is over here. So like that, we have different positions of bending the bar. If you will provide all the bar at one area, the concrete will not equally equally dense in that particular area. It will be like more rebar dense area, so which is not good for our building. So in general practice, the overlap length we will differ for certain rebar. Okay, so what I will suggest you, suppose this four member, the outside member, we will extend it, not extend directly, extend it in a sketch mode. Okay, so suppose I will extend this. Suppose I have extended it till 500 mm. Okay, finish it. So corner side, suppose I will extend it to the 500 mm. Okay, okay. So suppose corner I have extended 500 mm. So this is in group. No. Suppose this one I will extend till something 700, or suppose 800. So this is in general I have provided. But see, all these details which I have shown you, it's just I have not taken any reference, but all these things will be provided from the structural details in the drawings. So when you have drawing, see what I was suggesting to not to provide at one junction so that the concrete will not be weaker in this zone. So if it is like separate zone of overlapping, then the concrete will be pour inside well and the column strength will be very good. Also nowadays, instead of overlapping, couplers also we are using. What is coupler? Coupler is kind of joint which is like we can rotate it and it's a kind of cap so that it will be connected both the end of the rebar without the overlapping. So that is also using inside the project, but for now you can use the overlap length. Okay, so overlap length, you can notice the bottom rebar is going straight. Top rebar, you have to bend it from the 40 like certain degree angle, and then you have to overlap. So when you will work on the next level, suppose in this level, suppose you want to work on the coupler. I'll go to the level. This one. I'll provide one rebar. Okay. Okay, suppose I have to place one rebar over here. Suppose a 16 rebar vertical member I have provided. So when you are providing it, what you have to do, you have to start sketching at the same time. So in this way, you can sketch. At least 300 to 400 overlap you have to provide. Understood, everyone?
Yes, sir.
Then you can mirror it or you can place it on other junction as well. So this is how overlapping you have to do. So this is one example I have placed. You have to place it on other corners as well. Okay. Make sure when you are placing it, what's the best way to do? Suppose I have placed it over here. Now you can move the section little bit forward so that you can work well along on this particular two rebar. When you are going to this section again, now you will not see the other rebar so that you don't get confused, right? So this is the best way. Again, you can move the section and also not move till this rebar so that you will only see this two vertical rebar. Now, one more thing is this, like the rebar which we have provided, the tie bar which we have provided, it will also not overlap one another. So make sure while giving the spacing and while providing the spacing, it will not go all along, like not overlap also. Now, generally on each level, the beam will also come. So when the beam will come, I will draw the beam in this project now. So let's start working on the beam. So let's provide the beam. So beam also we called it as a frame, structural frame. So when the beam is there and the beam reinforcement will go inside the column, these tie of the vertical member will not go inside the beam because the beam is not, it is not visible, like the beam is not going inside the column. The beam rebar will go inside the column, and it these tie that time will affect the column. So how the beam and column junction will be there, we have to see those things as well. Concrete column. So the tie of beam will not go inside the column, but the vertical tie of the column will be well inside the beam. Only the beam horizontal member will bend inside the column. Let's see how we have to provide. Also, we will see the SP34 for providing the stirrups in beam. Beam is on starting from 97 page number. Now, when we will work on the beam, this is the basic example of beam. So at the end, there is a column. This is the center column. So what we are doing, this is a beam. Particularly, we can say it as end support, intermediate support. Like when the beam will come, when the column will come in between the beam, then it is intermediate support. Okay. Now there is a bottom rebar, the top rebar. Okay, and there is a top extra. Okay, and say mid span extra rebar. Okay, so like these three rebar we have to provide. So minimum top bar will be 2. Also for the bottom also minimum we have to provide 2. I'll show the section. So this is the particular section. So the first one. Again, when we are providing the beam, there is a top rebar at the top corner, bottom. Sometimes we have to provide this extra bottom. Okay. Now the tie. Okay. And certain stirrups too in between also sometime we have to provide. This is the particular section of the beam. Now in beam the stirrups we have to provide at the edge we have to provide more stirrups, and in the center we have to provide less dense stirrups. Okay, again on the other side we have to provide the tie stirrups will be more dense. Okay, so that thing also we have to consider. Certain time in the column also we have to provide in same way, like the top portion of the column stirrups will be more dense, and in between certain less stirrups will be provided, and also again on the bottom side we have to provide more stirrups. Okay, so those things will be described well inside the details how you have to provide. So during that time what you have to do, you have to make this group copy and place it till this end, and copy the group and place it over here. That I will show you in the beam, okay, so that you can understood. So let's start with the beam. So in the section only I am providing one another section so that it will be visible. In the plan also you can see this section. I'm providing one section over here. So in this section, this is the particular beam. So first we have to provide the cover. Now for the beam cover, the formula is in such way, like what is the beam depth? Based on that, we can provide the beam cover. So beam cover generally, suppose 600 mm beam, we can provide the 60 mm cover. Like that we have to provide. What is the depth of the beam? Based on that, so in general 25 mm cover we have to provide, but it depends based on the increasing the depth. Okay, so when the depth of the beam will be gets increasing, so we have to provide more cover, but we will not exceed more than 50. That is not good. More than 50 cover is not good. So for the 600 beam also we can provide 50 mm cover. Understood? So let's consider more than 25 only. Okay, suppose 30 mm. The 600 mm beam provide the cover. Okay, suppose I have provided 30 mm cover. Let's provide the rebar. Now in beam, generally we will not provide this much. The bottom bar, it's more strength, and the top bar generally provide less strength. So like that we have to understand, we have to place. Suppose top two bar is 12 mm, okay, and bottom two suppose 16 mm. Okay, certain time extra bar will be there, so that will be 12 mm only. Okay, now extra I will show you later. First I will provide this. Uh, tie. So again, the same tie. M01, which we have provided in the stirrups of concrete column. Same stirrups we can provide it for the beam. Okay. Also 8 mm only. Okay. Go to the section. So here basically we have provided. So what we have to do, have to provide the spacing, maximum spacing 150 mm. Now 150 mm. Also, we have to make sure this is like 50 mm outside from this column edge. That thing also we need to consider. Okay. And 1/3, like suppose this is the length of the beam you have to measure. Suppose 9500. So 1/3 you have to measure. Use the calculator. 90 divided by 3. So basically this much, suppose 3200 mm length, you have to provide the dense one. Okay. Let's provide a detail line of 3200 mm. So till this end, you have to provide the dense rebar. Okay. And then copy this group, place it over here, move around. Now depend on the spacing. Now we will provide 300 mm spacing. So 50 mm already. So 300 mm spacing, and provide the 300 mm spacing for this rebar. Okay. Also mirror this to the other side from the center. So like this, you have to provide the 3 different group of tie. Okay. Now sometimes again we have to provide extra beam rebar. Okay. So Now top extra and bottom extra concept, we will look inside the beam. Detail lines we can delete it afterward once we will place all the rebar. Okay. Now top extra. So what is the top extra? Go to the section. Place one rebar. Now also for this horizontal rebar, we have to do one more thing. What is the thing we have to do? We have to bend in its last edge, not provide the straight bar directly. How to bend? So once you bend, make sure that it will be well inside the column. Certain time you can bend it inside the column rebar, okay? So that it will not clash any one of the rebar. So this is what we have to check. Delete this one so that we have already sketched it in this area. So no need to sketch it again. Understood? Understood everyone? So like this you have to provide. Give the color different color so that you will understand what you are doing. Okay. So same way the top two rebar also you have to bend. Like this you have to bend here, here. Bottom extra rebar also you have to bend. So when you will provide the bottom extra, how to provide first the bottom extra? So let's provide one bottom extra. So either just I will copy this one. So and decrease the dimension of this bar dia. Place it just above the tie. So suppose this one single bottom extra is placed over here. And suppose two top extra bar is there. In section, edit the sketch. So bottom extra generally will be provided over here in the center of the beam. basically you have to understand one concept. The concept is, suppose we are seeing this beam. So concept is the beam will bend the with the help of its load. The center portion it's too much heavy. So when the beam will going down, we need extra bar here to support the bend. Okay. And at the corners, the load is too heavy so that it will bend from the edge. So that time also we need extra bar to support the top corner. So basically the concept is to provide extra bar on this corner and on the this corner joints, and at the center because of the load there is extra load. So basically rebars, what it will do, it will provide the tension means it will carry all the like tensile strength. Okay, compressive strength generally rebar is not, concrete is already compressive in nature. We need not provide so much compressive strength with the help of steel. We only have to focus on the tensile strength so that the crack will not happen in the beam. So more rebar when we will provide in the bottom and the top at the corner, automatically all the loads will be inside the beam. Okay. So what we have to do, we have to provide top extra at the corner portion and bottom extra at the center portion. So actually there is a length we have to consider, like suppose this is the L. L means from the center of the column to other center of the column. Basically the beam length will be, we call it as a L. So that we have to measure first. So let's measure the L. First I will draw a detail line. This is our column center. So from the center to this end, it is actually 10,000 mm. Right now I have provided. It will differ because basically we have our project room length or uh, any commercial place, the whatever the length of the commercial place, based on that our gallery or whatever the shopping complex, whatever, based on that the beam length will differ. So right now it's 10,000. It's easier to calculate, but when it will be having certain different length, then you have to calculate accordingly. Understood? So basically this side from the edge of the column we have to measure 0.0 L. So open the calculator again. Basically 0.08 multiply by 10,000. So basically 800 mm we have to lift, and then we have to start our we have to start our sketch. Okay, and what you have to do, you have to not provide in this direction, just provide in this direction, 45 degree. Okay, mirror it from the center. Or make sure to measure it from this end as well. I think it's correct, only 800 mm. So we are good to go. So this is how the bottom extra bar you have to provide. Okay, make sure to provide any different color. Okay. Provide the stirrups different color. So now we will provide the top extra. Also top extra, we have to bend it. So copy just this one and place it in the center. Edit sketch. So what you have to do, you have to measure the top extra length now. So top extra length, what we have to provide, where exactly we have to end from the edge of the column to 0.25 L1. L1 means effective span length, means center to center of the column. So basically it was 10,000. So 0.25 L1 means 1/4, means let's measure
2500.
2500, right? So we have to provide, and where exactly it's, we have to start from the edge of the column we have to measure it. Okay. So basically we have to end in this area. Also, you notice one thing, there's two length. Actually, one is one is, if there is only extra bar, then we have to provide up to this end. Another one is 0.15 L1. What is that? Sometimes we have to provide overlapping length from the column. So in that scenario, we have to provide the LD till this end only 1.15. Okay. But right now I am just focusing on the top extra, that will we will provide 0.25 L1. Okay. I already copied that one, so I will use this one. Edit a sketch. Also make sure to bend it at certain degree, 45 degree, and finish it at this corner. This one you can provide not too much. 150 or 100 mm is fine. Okay. So this is how one side, if it is provided, another side, you can just mirror it. Now, one more thing. This I have just provided in the center is not good. Basically, we have to provide it in the top extra will be we will provide it in the side portion, not from the center. So basically, we have to provide it somewhat here and mirror it. Okay, bottom extra we will not provide it in the side portion. Sometimes when there is more rebar we have to provide then only, but most probably we will provide it in the center. Suppose two bottom extra, so two bottom center we have to provide. Okay, but top extra generally we will provide on the corner. Okay, don't worry, like when you will see the structural drawing, that time you will see the uh, how exactly you have to do. I will provide, make sure I will provide the structural project today so that you can start doing the practice. Mirror it to the other end. Okay. If suppose the columns, the beams are continued from the other end, then that time the top extra we will also continue to the other end, and that time you have to measure the other side L, so that time the L will be different, and this rebar we have to continue to the other end as well, and that time you can see the code. Suppose this is L1 length, this is L2 length, so this length you have to measure from the L2 length. Okay, so it may happen like this side the bar length is small and this side the bar length will be big, or vice versa. Okay, so those things you have to consider while calculating the length. Understood, everyone? So
Yes, sir.
Okay, sir.
this is what we
At the
have to,
same time,
Depend
yes, sir.
upon span length.
yes, depend upon its span length, correct? So this is how we have to do the beam and column reinforcement. Now, many one of you will have doubt like how we have to do bigger projects, like one by one we are doing each rebar or each stirrups. No, not exactly like this. Suppose you have drawn this rebar of this particular beam, automatically these beam like 3 4 beam which is all along this area, we can copy just all this rebar and place it in inside the beam. Okay, certain time beam dimension it will be changed.
Different.
That time only little bit of adjustment you have to do after copying it. So many things, many hard work you can reduce with the help of this. Okay, while copying, just place it first and then again move the section and little bit of adjustment and all things are set. Means all the calculation you have done on one beam, it's fine. Other beam is just you need to copy. Okay. Only thing maybe certain beam in the other corner you have to also calculate, and then again you are ready to copy it and ready to complete the project. Okay, like this the work you will, once you will work on certain corner certain place, automatically you can start copying it. Suppose this one column you will do automatically, little bit of changes, maybe certain columns sizes will be changed, but uh, the dimension, the overlap, the extension of the vertical bar, those things you can just copy. Even the overlap length, just you can place it and you are ready to go. No need to place again from the scratch. Understood? So that is very go to inside the Revit, we can copy the things, we can mirror the things, and obviously it's very much easier once you will hand-on experience on certain elements again and again. You will notice like you will do the things quite faster. Okay. Now we have completed the column, we have completed the beam. We will just look the shear wall. It's very simple once you have worked already on the column. Very much easier now to understand the shear wall. So basically it's it's the wall, but at the same time you have to understand it is the uh, column as well. It is acting as a vertical column only. Okay, only thing is it's thin because it is in shape of wall. So what we have to do, we have to just provide the, suppose one shear wall you have to consider at one time. Suppose this is kind of shear wall, suppose for the lift it is provided. But what you have to understand, this one segment, we have to consider it like as a column. And all along the edge, you have to provide the shear reinforcement, like the vertical reinforcement. And that vertical reinforcement, you can place it in spacing. Okay. In shear wall, it is fine to provide with the help of spacing. Okay. Because the at the bottom in the foundation, the extension of the main bar, it is all along the horizontal wall. Maybe on the corner you can provide 45-degree, but throughout the wall you can provide in unidirectional extension. Okay, that is it. So shear wall, when you have to detail, it is quite easier only. And we have certain project in which you have to detail um, sump tank. In the sump tank also, you have to design the walls. You have to place all the rebars. So I will show you in the next session how to detail this. This will not take time, but main thing in the upcoming session, we will discuss more on the slab, and then the final thing is we have to do the detailing of stairs. Okay, but for now, you can practice all the foundation, columns, and beam. These three are, you are all good to go. Any question or anything you can ask me, and we will have to finish these things. Okay, I will provide the uh, project today so that you can do practice. Okay. Any question, anyone till now? No one. So okay,
Sir,
fine, everyone. Yes, yes, Badru.
sir, please share the YouTube link for this class because sir
Okay, okay.
क्लास में सिर्फ देखे कि क्या क्या होता है लेकिन पोस्ट थोड़ा डिटेल में थोड़ा
Okay,
समझे.
no issue, no issue. I will provide the links for the today's session as well. But make sure you will do the practice after that because I will remove the link. I will not provide the link till every time. Like you can practice today and you can watch all the doubts, and also I have to asked you to come to DCS so that if you have any question while placing the rebars, you can ask me in the dishes. Okay.
Okay, sir. Okay.
Okay, fine, everyone. Thanks for the today's session. We'll see you in the next session. Okay.